All right. Hey, everybody. We're here in Unit 1 of Algebra 2, Lesson 7. This one's going to go pretty quickly because we're looking at representing more sequences, and there's an info gap in here that we can only do in class. So when we look at this, 7.1 just starts us off with which one doesn't belong. And so you know that each one of these, we can find a reason why it doesn't belong compared to the others. So let's see what we have. Looks like we have 4 different recursive definitions. And I see that each one starts with the number 6 as the first term, except this one. This one doesn't start with it as the first term. It starts with it as a 0 term instead of a 1. So it's reminding us that there is a possibility that we can start actually with the 0th term. And one example of that we've looked at in our past is when we did the paper cutting. If you remember, there was a time that we found the area of the paper before we had cut it in half at all. So there can be times where we're not going to have any cuts. We're not going to have a single step. It's going to tell us what it's at to begin with. This is still a beginning term, and so are all of these. It's just saying that, hey, this one starts at 0, and that also changes this inequality here. So everything else, because it tells us the first term, the equation is good for every term larger than that. And instead, this one starts at the 0 term, so it can start with the first term and everything thereafter. So that is also why this has an n greater than or equal to 1, because the starting term is called 0. Okay, so I'm just going to kind of put it that way. All right, let's see what else makes something different. I see that we have a function that takes the one before it and it subtracts 5. And when I look at all the rest of my equations, this is the only one that has subtraction. So this is the only one that uses subtraction as part of our function, our pattern to find the next term. And so because everything else is either multiplying or adding something different each time, we'll talk about this one next. This is our only arithmetic. It is our only arithmetic sequence. All right. I see that D is the only one that has a variable in the equation. So this idea that it has uses a variable in the equation. Now, of course, the rest of these have this f of n minus 1, but that just means taking the previous term and doing something with it. This one, we're going to add something different every single time. So what this is saying is we're going to start with the number 6, and then we're going to add whatever n squared is. So for the second term, term 2, when n equals 2, to find our second term, we would take the first term, 6, and we would add n squared. So n squared equals 4. So 6 plus 4, our second term is going to be 10. Then it says for the next one after that, we're going to take this one, and then for the third term, we're going to square 3 and get 9. We're going to add 9 to this number, so that would be 19. So this one is neither geometric nor arithmetic. And I think it's our only neither equation. This one's arithmetic, this one is geometric. This one is also using multiplication, so it is also geometric. So this is not only our only one that has a variable in the equation, it's our only neither equation. Cool. All right. So the last one to look at is B and what would make B different than the others. Everything, let's see, this is growing, oh, that's shrinking. It's our only one that has a fraction. We could say that. It's our only fraction. Okay, and remember that multiplying by half is the same as dividing by 2. So we would have 6, and then half of that is 3, and half of that is 1.5, and that's what our sequence would look like. But it's our only fraction in our equation. So we do have an info gap. We're not going to do that here. This is also just kind of reminding us that we're going to use repeated steps over and over again to find some patterns. We can do some graphs. And then if we look at our cooldown, if you have this with you, if a geometric sequence, remember that means it has to use multiplication or division, starts out as 12 and then 6. To write a recursive definition for function g, sequence g, I'm going to say, well, our first term starts at 12, then every next term takes the term before it, and let's see what it does. Let's see, if I can only use multiplication or division to get from 12 to 6, I would have to divide it by 2, or we could multiply by 1/2. So that's how I'm going to get from one to the next for every term number 2 and larger. So to sketch a graph of what this would look like, the first 5 terms of the sequence, I might need a table to set up my first 5 terms, or I might need to list them out. So remember, there's lots of different ways to represent a sequence. If I start with 12 and 6, they gave me those first 2. I need to find 3 more so I know how to graph it. So the next term, if I cut that in half, is 3, then 1.5, and then 0.75. Okay, that helps me know the first 5 terms. The biggest number in my sequence so far is up at 12. So the first term is there at 12. Second term is cut in half here at 6. Third term cuts it in half again at 3. Fourth term cuts that in half, and so it's going to be this kind of downward curving graph. That's it. Go check out some practice problems for lesson 7.